In this video we'll be looking at logarithm theorems. The logarithm theorems are used to help us simplify. They're used to help us solve both logarithmic and exponential functions. So that's the reason why we need to learn them. And it says here they must be memorized. You will memorize them over time on a quiz and test. I will make these available for you for my students. But as you use them enough, you'll start to memorize them. These down here aren't theorems, but when you see them, you need to recognize them. So notice in both cases here, the base for the logarithm is b right there, and the base for the exponent is b as well. So the bases are the same, so you're just left with this part. The answer is just p. Whatever is in this location will be your answer. It's equal to that. And same thing here, the base for the exponent is b, the base for the logarithm is b, so you're just left with this part right here. That's how it simplifies. Alright, and when you see that pattern, you're going to simplify to just be that or that. Whatever's in that location will be it. So example 1 is actually one of those. Notice the base for the exponent is 6. This is the base, this is the exponent up here. And the logarithm has a base of 6, so they're both base of 6, so we can cross those out, and we're only left with the 13. So answer here is just 13. Alright, let's look at example 2. Similar situation here. Our logarithm base is 2, our exponent base is 2, so they're both base of 2, so we just are left with that when we simplify. So this one is just x plus 5. That's it. Alright, let's look at the next one. Alright, this example 3 says expand. So we're going to be using these theorems up here to expand and to condense. So when you expand, you go from less to more, like that. So you're going basically from this left-hand side to the right-hand side. That's when you expand. You go from less stuff to more stuff. And when you condense, you're going from more stuff to less stuff. You're condensing it down to be less. That's one way that you can look at it. So the vocabulary there, when you expand, you want more when you're done. When you condense, you want less when you're done. So expand this, log base 4 of 4x. So we have log base 4 of 4x to start with. So we're multiplying 4 times x here. So we can expand that to be log base 4 of 4 times, or pardon me, plus log base 4 of x. So that is applying this rule right here. Okay, we're going from multiplying the argument in here to splitting it into two pieces, adding both of them. Okay, that's what we just did there. So log base 4 of 4 though, that's just 1. Log base 4 of 4 is just 1. Notice the base is the same as this number right here, so that's just equal to 1. So it's final answer 1 plus log base 4 of x, and that's your answer there. Okay, why is log base 4 of 4 1? Well, let's think back to our last lesson. Log base 4 of 4 equals what? So 4 to what power equals 4? Well, 4 to the first power. So that's why log base 4 of 4 is equal to 1 right there. So that's why we put that 1 there. All right, let's look at example 4. Alright, example 4, condense log base 3 of x plus 6 plus log base 3 of x. So we're adding these. When we condense, we go from adding to multiplying. So we're using, I've gone ahead and pasted this down here, we're using that one. So we're going from more stuff and now less stuff. So notice the bases have to be the same, just like when you apply exponent rules. When you apply these logarithm theorems, your bases have to be the same for this to work out. So it ends up being log base 3, and now we're going to multiply this x times this argument, x plus 6, and then distribute that in the next step. So log base 3 of x squared plus 6x. And that would be, put that all in parentheses, so that we need to do that so that it shows that the argument of this logarithm is this whole quantity. It's not log base 3 of x squared and then a plus 6x out to the side. So you do need to put this argument in parentheses. So now we went from more stuff to less stuff. We had two log base 3's, two different terms there, and now we're down to 1. So we condensed it. All right, let's look at the next example. All right, example 5, expand. So we're going from division, and then when we expand that, we're going to be using subtraction to do that. So I've gone ahead and brought that theorem down that we'll be applying here. So we're going to go from the original to log base b of x subtract log base b of y. So the top number we list first, or the top variable in this case we list first, and then we subtract from that the bottom one. So we just fill in this pattern. That's all we did. The top number, our top term went there, and bottom one went there, and we're subtracting it here. So we expanded, so we went from less to more. All right, we just applied this theorem right here. Next example will be number 6. All right, now example 6, condense. So we want to go from more to less when we condense. So we have log base b in both cases, so we can apply these theorems over here. And we want to condense, so we're going to go from subtraction to division. So we're going from this over here to this left side. So from the right side of the theorem to the left side when we condense. So it'll be log base b, and then this number goes on top, and this part right here goes on bottom, and we'll go ahead and put that in parentheses to show that we're taking the log base b of this whole quantity right here, 3 over 2y. And that is condensed. We went from more stuff to less stuff when we condense. All right, example 7 is next. All right, 7, expand ln of x cubed. So ln, remember, is the natural log. It could also be written this way, log base e of x cubed. This is the most common, so that's the way we're going to leave it. But just wanted to remind you that ln just means log base e. That's all it means. So in this case, we're expanding, so we're going to go from more stuff to less stuff to more stuff. When we expand, we want to expand it out. So right now we have it in this form right here. It's ln of x, and it's got an exponent up here of 3. That's this. In that spot there. So now we can take that exponent and move it in front as multiplication. That's what this rule right here, this theorem right here does. You take the exponent that's in the exponent location and you pull it in front as a multiplier. That's what's happened here. This n that was an exponent is now this n in front as a multiplier. So this one will simply become 3 ln of x. So we just took this 3, we moved it in front, and now we've expanded that. We went from the left most theorem to the right most theorem. So when we go to this side again, we will be expanding, and vice versa when we go from the right to the left, so we go this way, we'll be condensing. Condense. All right, so let's look at example 8 next. All right, example 8. So it says condense. So we're going to go use our theorems on this side, or this side of the theorems, to move them over here. So we're going to use, we're going from right to left in our little list here. The order doesn't really matter. You see we have 3x log of 4. There is an implied 10 there. We don't have to write it, but since there is no base listed, remember from the previous lesson that the base is 10. So all that we have to do here is take the 3x multiplier in the front and move it up as an exponent. So the only theorem we're applying here is this bottom one right here. So we're taking the part that's multiplied in front and we're going to put it as an exponent at the very end here. So it would become log of 4 to the 3x power. All we did, we took that front multiplier up here as an exponent. And that would be it. Log of 4 raised to the 3x power. Again, we don't write it, but there's an implied base 10 there if nothing else is listed. Alright, let's look at 9. Alright, here on example 9, it gets a little more complicated because we'll have several steps here. So we want to expand. So we want to go from the condensed version to the expanded version over here. So we're going to start with the condensed version and take it to the expanded. So the first thing that I noticed is we have this theorem that we can apply because we're dividing here in this logarithm, so we'll do that. the numerator will be listed first here, and the denominator will be listed second here. So the numerator 5p squared first, and then q cubed, the denominator second. So numerator first, I don't know if I said that the first time, numerator first, denominator second. So it's the log of 5p squared and subtract the log of q cubed. So numerator here, denominator here, and we went from division to subtraction. All right, next we have a multiply going on here, so we're going to expand that. So I'll use another color here. So it would be log of 5 plus log of p squared minus log of q cubed. Okay, so what we did, we applied this theorem right here. We split this multiplication, this part, into addition here. So we split that, we expanded it. Notice it's less here, it's more here. So when you go from, when you expand, you want more stuff in the end. Okay, last thing that we can do, we have this exponent right here, and we can apply this theorem and pull it in the front because we want to expand as much as possible. And this side is expanded, this side is condensed. Right now it's in this form. We want it to look like this. So we're going to take that 2, pull it in the front, and we'll be done. So log of 5 doesn't change, plus now 2 log of p, so the 2 came in front, minus, and this last part doesn't change, q. Actually, we need to do the same thing here, just solve that. So this 3 needs to come in front. We'll apply the same theorem. We could have done that in the same step, but I didn't. So final answer, log 5 plus 2 log p, subtract 3 log q. Now it's fully expanded, and that is our final answer. So be careful and just make sure that you've expanded as much as possible. All right, let's look at the last one. All right, now for the last one, example 10, they want us to condense, so we're going to go from this side to this side. We're going to use our theorem in that way. So first thing that we can do is take care of this 8x multiplier in the front of that logarithm and that 2 multiplier in the front of that logarithm, and we will be applying this rule right here. So we're going from this side to this side with that theorem. So looking at this, it becomes ln of 4 to the 8x, that's this part. The 8x just came up as an exponent there. Subtract ln of 4x, that doesn't change. And then plus ln of the quantity x squared plus 2, all raised to the second power. Parentheses better there. All raised to the second power. So this 2 came up here as an exponent. Okay, now we can apply our addition theorem right here. So from addition to multiplication, so we're actually adding, notice this term, this logarithm right here, this part is negative, but this and this are positive, so we can add those. We're adding those right now, so we're going to make them into 1 and have them multiply. So we have ln of 4 to the 8x times x squared plus 2 all squared. So we're taking that, and then we still have this minus ln of 4x. Now we can take this subtraction right here and apply this theorem and turn it into a division. So this part will be in the numerator, this part will be in the denominator, all with just one natural logarithm. So ln of 4 to the 8x times x squared plus 2 all squared all over 4x. All right, and that will be our final answer for that one. And it wouldn't hurt, let's put this whole quantity here in parentheses because we are taking the natural logarithm of all of that. Okay, so we went from, in the beginning, more stuff, and now we've condensed it down to less stuff. So now just one, we're taking the natural logarithm of this whole quantity instead of taking the natural logarithm of these individual pieces. So that's what condensing does. All right, that's it for this video, and that's it for this lesson.